Alright guys, welcome back. Today we're doing something pretty interesting and pretty fun. This is something that's long overdue for me. I had a NAS before, I do not use my NAS anymore, and then I thought it was, a good time to get a new one. Now I didn't want to go with like the traditional route, like buying just a classic NAS enclosure and then just figuring stuff out. I wanted to do something more fun, so maybe you can tell from here, from the boxes, I bought something much funnier. I bought a Raspberry Pi. So I know that there's a lot of ways of making NAS these days, and for the few of you who don't know, a NAS is a network attached storage. So basically what it means is that you have like a SSD or HDD, like a drive that you can access online. So basically it's a local and homemade alternative to cloud services, to make it very simple. So say instead of storing your photos on iCloud or on your actual computer, you can store them on your own server, which is your own cloud, if you will, and you can connect to it from your phone, your computer, your tablet, maybe your TV if you can, and then that gives you a full control on it. Now the thing is that for most of you it doesn't really make a lot of sense, because you guys are using the free tiers of these cloud services, let's say iCloud, Adobe Cloud, whatever. After a few years I've realized that the free tiers are great, but then a lot of features are locked, and then a lot of features that I would actually use were locked. So then I started going with the lowest tier, usually $2, $3, maybe $5 a month, and then you're like, $5 a month, not that much. But then again, you have Adobe Cloud, and then you have Canva Cloud, and then you have Google Cloud, and then you have iCloud, and and you keep on adding cloud services on top of each other, and then you pay Netflix, and you pay Spotify, and then you pay Disney Plus. There's all of these subscription fees that keep on piling up. This is where I started having an issue. Is like, it costs me a whole lot of money per month and a whole lot of money per year. So I was thinking, okay, things are scattered around. I have data everywhere on my PC, on my phone, on different cloud services. I basically have, pretty much no control over them. If tomorrow iCloud shuts down, which obviously is not going to happen, but if it did, then I would lose all of the data if I did not take actions quickly. So that led me to making my own NAS again. But like I said, I did not want to go with the traditional, I would say, normal way of doing it, buying just like a NAS enclosure, slapping some drive inside, and then just, use it. I wanted to make my own completely. And then the Raspberry Pi was a long time purchase I wanted to do. I had a Raspberry Pi 3, I think, that I used for a few years for a bunch of things. But it was like a very small one just to test, and I didn't use it very much. So I bought a Pi 5 with 4 gigabytes of RAM and a bunch of stuff. And so today we're gonna build a NAS together. Okay, so let's go over what's in the box and what do we have. So we do have a Pi 5, like I said, right there. I'm gonna go and do a bunch of close-ups after, and we're gonna build it together so you're gonna see what's going on. But we do have a Pi 5. We do have a active cooler for the CPU, which is a tiny PP little thing. This thing is so tiny, it's actually crazy. I recently put my computer back in air cooling, and I do have this low-profile 90mm cooler. And these things are very compact. I was really impressed of how small it is and how efficient it is for that size. That thing, my friend, is like, it's like 2 squares of chocolate. That's very funny. I bought the official power supply of the Pi 5, and then you will see why. There's many ways of powering your Pi 5 and any other Raspberry Pi anyway, but the official power supply has a special purpose for me, and you will see why. I do have, I'm gonna have to open that one because you're not gonna see what it is, because they slap 1900 stickers on that box, so you can't even see what it is. I bought a USB to Ethernet because the Pi 5 comes with a 1 gigabit speed Ethernet card. This is a 2.5. For the few non-nerds of you, it means internet go speed. Good. That's what this is. Internet speed good. That's it. So we can probably, exactly. These are the drives, and this is the card that I'm going to use to boot PiOS on. But I do have to show you why I'm using a Pi 5, because a lot of you are going to think, how are you going to power a bunch of drives, and what kind of drive are you power with a Pi 5, right? So where's the fun? I was browsing around, and this is in the middle. I found a top hat for Pi 5, which I'll show you in details after, that hosts 4 NVMe drives. That thing is nuts. So obviously, a few nerds of you are gonna say, yeah, but that's a Pi 5. You have a bunch of NVMe's and a 2.5 gigs card. It's not gonna be full speed. It's gonna be okay speed. True, it is correct. It is not gonna be as fast as the NVMe's can be, but it's gonna be just so much more fun and so much smaller. So I bought, I think one of them is open. Yeah, well, half. Here we go. So for now, I only have 2 only, because these things are expensive. These are 1 terabyte NVMe's, and I have 2 of them. So this is just one, this is the heatsink. But I do have, in total, 2 terabytes with me right now of NVMe, and I'm just gonna buy 2 more terabytes. So two times 1 terabyte extra to make 4 1 terabyte each, which means you would have 3 terabyte of storage and 1 redundancy to protect your data. So what it means is that one of the terabyte is gonna be completely used and locked. In case one of the 4 drives dies, that extra drive is gonna replace the one that just died. So here's why we are going with a Pi 5. And that's gonna be great fun. All right, so I'm gonna switch the camera position, put it next to me, grab a screwdriver, and we are gonna look into what do we get and how do we assemble all of that. So I'll catch you in a bit. All right, cool. So now you can see the workbench. So let's go over a few specs, right? So we do have the power supply, like I mentioned. This is a 27 watt official Raspberry Pi, which is a USB-C powered. 27 watt is what gives you enough power to power both the PI and the board. So speaking of the board, before we go to the Pi, sorry, I'll keep on saying the PI. And it's my fault, is because I kept on saying PI to tell the person I was talking to how to spell it. But that's Raspberry Pi, obviously, because that's, that's the point of the name. So that board is the X1011. There's a bunch of different manufacturers. That one, I have no clue what's the name of it. It's like some Chinese brand that just doesn't make a whole lot of sense. But I know, oh, this is Subtronics Technologies, right? It's actually right there, it's called Subtronics Technologies 4M.2 NVMe SSD Shield, X1011 version 1.1. There's another very known brand that's like Geekworm on Amazon that you can actually get. I was hesitating between between the 2 of them, but ended up buying all of them in the same place because we have an English is hard, I'm sorry. We have an official store of Raspberry Pi in my country, so we can order all of the supplies officially from them, which was, a bit better. A few things to note about this board. It has a DC 5 volt barrel supply. I don't know if you can see it, probably not right there. So it has a barrel supply that you can use. It's a 5 volt. You have to be very careful. It has to be 5 volt, not 12. Don't just cook the whole thing. Although I am not entirely sure if this barrel can supply both the 4 drives plus the Pi. I did have some concern going that way. They do mention, very importantly, to not use the barrel plus the USB-C at the same time. You have to pick either or, because if you use both, I think you probably short the board. Either that one or the Pi, doesn't matter. And it does have, so you have 3 pogo pins right there on the top of my nail. They're right there, these 3, and do make contact on the solder joints of the USB-C. I'm gonna show you after. So that's how they get power. And then you have obviously the PCIe slot where you're gonna use the ribbon cables, which are right here. They apparently always supply 2 of these to you because they're obviously kind of tiny, right? These are very small ribbon cables. And this is the ribbon cable that's gonna connect the data between the main board and then the daughter board, which is our NVMe board. Okay, let's go into the most important part. Here's our Raspberry Pi 5. I hesitated taking the number 4. I am not sure if my hands are in focus actually. Yeah, seems okay. The Pi 5 is the new version. It is much more powerful than the 4, but for a NAS, for a server, it doesn't really matter, honestly. I just picked that one because of the price, basically. Okay, so let me just wash my hand because I have some sticky thing, and then we can start. All right, cool, I'm back. Sorry for that. Sticky hands is very uncomfortable. So as I was saying, we have the Pi 5 here, and then we have the cooler, and then the daughter board. Let me show you the cooler. I was not lying, that thing is very small. Look at this. This is insanely small. That's crazy. And oh yeah, forgot to mention, not that it makes any difference for what we're doing. Honestly, if you do replicate that, first, don't. That's very stupid. Second, if you ever do it because you don't care, don't spend too much money on the drives themselves, apart from taking a reputable brand for longevity and for the quality of the controller and memory chips in themselves. It doesn't really matter, honestly, because they're going to be bottlenecked by the Pi and then the X1011 board. Because the microcontroller here on the board does not allow for the full speed of each drive. It gets saturated it gets to a limit of about 200 megabytes, 250 megabytes transfer. So it doesn't really matter. And then buying an NVMe over SATA drives, like 2.5 inch SSD, not that big of a difference, honestly. There isn't that much of a difference in terms of speed because of the setup you have, because of how the transfer data is. Data transfer, English. Oh boy. And then, yeah, we do have a SanDisk. I'm just not going to show you that, who cares? It's just a whatever SanDisk SD card into a USB driver, USB drive that you can read on the computer. That thing has 64 gigabyte, which I'm a little bit pissed about. I did have a 32 and I cannot find it. You really don't need 64. 32 top, 16's enough. Don't have any 16, have a 32, can't find it, so I'm gonna use a 64. But to be very honest with you, I'm a bit pissed because 64 is overkill and I'm never gonna use that. Although cache and apps can go bigger, yeah, that's gonna use this. Anyway, so yeah, let's get into building that thing, right? Like this is what we want. Oh, and for the case, by the way, I forgot to mention, I'm gonna 3D print the case to hold the whole thing. Because I do, obviously have a 3D printer, so I can make something pretty cool. All right, let's get into building the thing. Let me zoom in with the camera so that you can actually see what I am doing. Okay, so we do have a, oh, you have to be careful because I don't have to go too high. Let me unzoom a little bit. Yeah, we do have a few thermal pads that are going to be on our memory chips. It is better if I put the cooler the right way, like so. Yes. And then you just push the plastic pins. Oh, this one is a bit tricky. There we go. And then there's those springs, so it holds it nice and tight. And then you just plug your fan cable in the right way would be better. Oh wait, that's not the fan header, is it? Oh no, it's not. My bad. That is not the fan header. Okay. Fan header is on top, and then there's a small cache. So let me uncap it. There we go. And you probably cannot see anything, but I am just connecting the cable to the slot. So it's not like you're missing anything. Right, and it goes right up at the top, right here. There we go. So that is our CPU cooler. I am going to take a screwdriver bit. Okay, so the next logic step would be to get the two SSD out and then put them onto, that's gonna be loud, I'm sorry. These packaging are not fun. There we go. I have a slight concern with the microphone right now because my microphone seems not moving all that much. So I'm concerned it's using the camera microphone, and if it is the case, the quality is not gonna be amazing. Okay, so let's go over. Something smells really clean. I don't know what. Oh, it's this. Oh, it smells like men perfume. Or you know, like these wipes that you can use. I don't know why. Okay, anyway. So this is your NVMe, right? You have the 2 memory chip and a small controller. You have a tiny heatsink, which is, you know, pretty thin, but decent. That is one of the reasons why I bought this one in particular, because then I can use the heatsink directly. I don't have to buy a third party, but we have a 3M sticker, so we have to install that thing. So we have 2 of these to do. Doesn't have to be mega precise, but it has to be pretty decently stick in there and not obstructing the screw. And it looks like this. You've got your heatsink. So we gotta do the same thing on the other one. By the way, I don't think building this on a cork plate is a very smart idea. But, you know, who cares? If it works, it works. Here we go. We've got your 2 heatsink. So let's get into that board. Ooh. There's a decent bit of resistance on that thing. Okay, we get a bag of screws right there. I am not sure what screw is for what, but considering there's only 4 of these metal ones, like silver ones, I'm gonna assume these are for the... my screwdriver bit's way too big. Yep, seems like it checks out. No need to over tighten, we just need to hold. Doesn't have to be tight whatsoever. Up, second SSD. I have done a very poor job at putting these stickers straight. If you want to make it look cool, don't do like me. Just spend more time putting these heatsink on so that it doesn't look like... Yeah. Hey, not too bad once you're together. Okay, that one is terrible. Alright, here we go. Heatsinks are in. So 2 SSDs. Next time I'm gonna put the 2 next. Yeah, very funny sentence. Next time I'm gonna, like next month, once I get my money, I'm just gonna buy 2 more and put them right there. Most likely the same as these 2, because then they have the built-in heatsink. It's pretty good. Alright, let me just put these screws back in. Actually, no, we do not want to space them. They're spaced enough. We don't have to add more. Okay. And here we go. Now we do have to connect these 2 together. It shows you which, I don't think I will be able to show you that on the camera, but it does tell you which side goes to the Raspberry Pi and which one doesn't. So if I flip it, you'll see it's going to be written Pi5. I am not sure you can see that very clearly, probably not at all. But I swear, it is saying Pi5. Please do the autofocus. There we go. Raspberry Pi 5. So you know which side goes where. So you do have to lift very gently this little brown part is the part that holds my battery right now. So I was saying you have to lift that tiny tab to, you cannot see anything. Let me zoom in a little bit. You have to lift that tiny tab and then slot the ribbon cable in and then gently press that tiny tab down to force connection. And now this is completely on, right? And then you have to do the exact same thing on the other side, but instead of pulling it up, I think you have to, oh, never mind, you have to pull that one up as well. I don't know how well you can tell, but that tiny tab has been pushed up like a small, I don't really know how to say that sentence. Just fill in the blanks, okay? You know what? Fill in the blanks. I'm doing the build, you're doing the English. All right, and then our two boards are connected. You cannot see them. Great. Here, connected. Yay. Okay, let me unzoom a little bit. We are going to do the second half of it, which is a bit more delicate. We are going to screw our Raspberry Pi onto that board, and then the build is going to be over. Just have to plug in the card and then plug in the power supply and just install, and that's it. Okay, so I am going to use the black screws that they provided, which I will assume are the black screws you need to use. How many of them? 4. Yeah, should be all right. They all have the same length, so once again, we do not want to over tighten all of that. We just want to give it a resistance check. When it's holding and you can feel the first resistance, you want to stop screwing, because you do not want to strip one of these screws, because that would be a huge mess to fix. Okay. Okay. And here we go. Is the pogo pin good? Yeah. So like I said earlier, I was mentioning the pogo pins, and you can see them here. These 3 bullet looking tiny pieces of metal. They're actually making connections on the USB-C, and I'm assuming this is to grab ground. So these 3 are basically giving you plus, minus, and ground. I'm not sure which is plus, which is minus, but you get the idea. It gives you power and ground. So you have energy going through. And then we still, oh, that is a clever design. I was wondering why these, I'm not sure you can see it through, but why is this ribbon cable like having this type of like S shape? You cannot see my hand. It has a small, you know, like wave shape. And it is because, I'm not sure how I can show you that properly, but right below the cable, exactly where my nail is, you can probably see there's the SD card slot. So this is where you're going to put your SD card, which is going to hold your operating system. In my case, I'm going to use Raspberry Pi OS Lite, and I'm going to transform it into Open Media Vault, which is going to help me manage the NAS, simply. So that's it. This is a currently 1, but soon to be 3 terabyte server. And the only thing you need to make it fast is to do, wait, let me use that one. This, there we go. You can plug your Ethernet cable in there. You hide this somewhere, whatever, how you want. And then you plug a USB power, which is that one that we unboxed earlier. Plug it in there, Apparently I'm a monkey, I cannot plug a USB-C. There we go, USB-C plugged. And then you press the tiny little power button right here. This tiny thing, I don't think you can even see it. It is this is a power button. Yep, and that's it. You have a NAS. I mean, almost. Now we have a physical NAS. Now we can actually build the environment, get the drive to work, and then 3D printed case. But it's getting there. All right, let's go to the next step. Okay, so day number 2. We're now going to install the OS and OpenMediaVault on the NAS. Yesterday I ended up just cleaning a few things and then just, calling it a day. So I'm gonna do it now. So what you need is obviously, well, the NAS, and then you will need an SD card. So like I said, I'm gonna use a 64 gigabyte. This is a SanDisk Ultra. Please use a pretty good SD card, like try to grab a good brand, because if you buy a cheap unknown brand, there's a chance this SD card is just gonna die at some point, and then you would just lose your OS. So you don't want that. So what I'm gonna do is I'm gonna plug it into the computer. I do have a card reader, and then here we go. We are going to download PiOS. We are gonna go with PiOS Lite, and we want to take the 64-bit. So I'm just gonna download it. What we're gonna do is that we're gonna install the Raspberry Pi imager. I'm using Linux, so it is going to install a package. If you're using Windows, it is going to be a little bit different, but it shouldn't be that different. All right, let me just remove this. Cool. So we do have our imager. So we have to choose which of the Pi we want. We want the Pi5, we want other, and we want Raspberry Pi Lite. And then we are going to use our USB stick. I want to see if we can change a few things here, or if it is after. Yeah, it has to be after. Oh, here. And then you want to edit the settings. This is the important part. I'm going to move this away. This is the important part. So you want to enable, you want to go to services and enable SSH. The reason is because you're going to access this thing remotely. So my router is on the complete other side of the room. I do not want to have a HDMI cable across the entire room, so I'm going to use SSH to connect to the NAS. You want to use a password for authentication. You do not want to use a public key. And then you want to set a host name. I'm going to leave it as raspberrypi.local. I think it's fine. I'm going to create a password. This is going to be my LAN, which for some reason is already connected, which is great. So that means it's taking the one from my computer. That's perfect. Wireless line country. I don't think that matters. Didn't even know it's a thing. So let me, okay. Oh, you can grab it like this. Let me configure mine and then hit save. Yes. Yes, you want to wipe. Okay, and it is writing. So now it is installing PiOS on the SD card, and when this is done, we're gonna go and install it. I'm probably not gonna show you because it's a bit messy, but I'm just gonna go and plug all of the things together, put the SD card in, let the PiOS start, and then once it's started a couple of times, it's gonna create some system files it needs, and then we're just connect to it through SSH. So let me open the terminal. So the Raspberry has rebooted a couple of times. It takes about, I don't know, maybe 5-10 minutes. So let's connect to it now. So you're gonna want to do SSH. Then you're gonna use the user that you said, add the name of the the name of the host, and then .local. This is what I have done. Now I need to type my password. Need to type my password. I cannot even speak. And here we go. We are connected to the NAS. So I'm just gonna clear just to make some space. The first thing you would want to do is to do a update and upgrade to make sure that everything is my bad. To make sure everything is up to date. Yes. This is important so that you have the last dependencies, and then you make sure that everything is running smooth. You don't have any issues. Then we're going to install OpenMediaVault directly from the repository. So I can make it a bit more clear. And then we're just gonna let it install. We are a little bit later in the day, so you can tell. Change my clothes. So it finished. It took about, I'd say, probably half an hour. So when you're doing this, expect this to be pretty slow. That is normal. There's a point where basically it's trying to remove some parts of PiOS Lite to build OMV on top, and that thing took probably 20 minutes, and it actually disconnected me from the Raspberry because I think it took too long. So that is completely normal. Don't be afraid. It's fine. Just use SSH again and then connect back to see what's going on. You should still see the installation running. If not, then technically it's maybe over. So I'm gonna go into Raspberry Pi.local. So basically the name you set when you installed OS, and you should see OpenMediaVault. Let me put it in full screen. We don't need a terminal anymore for now, so you should see OpenMediaVault. Your default should be admin, and then your password should be OpenMediaVault, full low caps. And here we go. We are in OpenMediaVault, so we technically have almost a NAS running. We just need to set the array, figure where the disks are. I can see both of my disks here, which is perfect. So I'm just gonna do just that, just prepare the array and stuff, and then that's pretty much it. That's how you build a NAS. I will make just two small notes. So the first one is, when you use PiOS Lite, make sure you use the, what is it called? Bookworm? I think it's called Bookworm. There's two versions currently. There's one of them that's Trixie and the other one is Bookworm. Make sure you use Bookworm because the other one, the Trixie one, just does not work. It is not compatible with OpenMediaVault. I cannot speak for TrueNAS. I don't know if that matters, but for OpenMediaVault it does matter. Then now I just need to figure a few settings, make sure it's secure, change your password, and then prepare the NAS so it's accessible. I am actually going to install a bunch of apps on it. I'm going to install Nextcloud and the other one, which I just forgot the name of. It's a collaboration app, so that allows you to use it as very similar to something like Google Sheets or something. You can just basically open a sheet and have someone else using it at the same time without having issues. So I'm going to install these. I'm not going to show the whole setup, all of that, because, well, for security reasons, second because it's not very interesting, but there's a lot of very good tutorial on how to set up MediaVault, regardless of how you've installed it to begin with. If it was using OpenMediaVault on like a Synology NAS, for example, you can definitely. I wouldn't recommend, but you can. So anyway, if you're using OpenMediaVault, there's a lot of different good tutorial out there, so you can probably follow these. What we will do, maybe before we quit, we are going to set up the dashboard. So when you go to dashboard, you can click setting page, and then you can see the disk temperature, load average, Smart status, the services, uptime we don't really care. Yeah, I think that's about what I want to see. Okay, so now it's gonna just load a little bit, and then it's gonna tell me what's going on the NAS currently. So there's absolutely no usage. Both NVMe are at 25 degrees because we're not using them, but that's very good. And you can see the uptime and a bunch of informations here, which are pretty good. Yeah, so I'm gonna leave that part here for you. And then now we're gonna do 3D printing, and then we will assemble a NAS, and that's gonna be it. All right, so we are day number 3. As you can tell, I changed my clothes for the 15th time. And the enclosure just got out of the 3D printer, so I just assembled it, and then yeah, that's it. The NAS is ready. I mean, the enclosure is not exactly perfect. I can see it's bulging a little bit. I don't know if you can tell, but yeah, it's been a bit rough, but that's fine. I can definitely print it again and fix that. This is really not much. It's a very small fix. So you have your Ethernet card that goes on the side, and you can tidy it a little bit. I can probably sticky tape it or something so that's a bit more compact. You can see it like this. And then the power USB-C is gonna go through here, and one of the things that I kinda like with this enclosure is, I'm gonna put the link in the description. Obviously it's something I found on Printable. It is not something that, Printables, sorry. Ooh. I think it's the wrong screwdriver bit. But one of the things that I like is that you can just unscrew 2 of these. You cannot see what I'm doing, but you can remove 2 screws, and then you have access to the SSD tray, right? So you can add your 2 extra SSDs and then put the 2 screws for the SSDs without having to disassemble the whole thing. I found that pretty cool. Whoever designed that, I'm gonna put the link in the description. Like I said, that person deserves a beer, and if they don't drink alcohol, then a hug, and if they don't like hugs, then $5. That's what I'm gonna say. My hugs are worth $5. So yeah, anyway, enough rambling. This is the small tiny NAS that's gonna go behind my router, and then I've configured it. Everything works. I have access to it. It's amazing. So thanks for watching. I hope this was interesting, entertaining, whatever you call it. And I hope you will do yours. And if you do, please send me a DM. I want to see. Show me some pictures. All right, I'll catch you later. See you guys.